experiment. Today's experiment is about esterification, preparation of esters, identification of the alcohols, or identification of the acids. Two parts of the experiment, and part one of the experiment, based on the lab manual, you will be assigned a group number, group 1, 2, or 3. And also for each group, you have 2 esters to prepare. But since I'm recording and I don't have other groups, and I am your lab partner, I'm going to prepare all 3 esters of A, B, and C. And based on the smell or odor, and we are going to identify which combination gives like what type of the esters and the connected to the odor. This is the known part of the experiment, or part 1. In part 2 of the experiment, I'm using 1 alcohol, which is butanol, and I'm going to mix with 3 unknown acids. And based on the odor, you need to identify which acids were combined with the butanol or 1-butanol to prepare the esters. Esterification, or specifically Fischer esterification, is a reaction between carboxylic acid and alcohol. When you look at the chemical equation or overall reaction, you can see that this reaction it can be classified as a nucleophilic substitution reaction. And in this reaction, you have a leaving group that has to leave, which is the OH group. And I'm not talking about the mechanism of the reaction. I'm just talking about the overall reaction. And you have a nucleophile of alcohol. So if you examine your nucleophile is not a strong nucleophile. You examine the leaving group is a bad leaving group, or is OH, which is not a good leaving group. So you have to use a catalyst. So we are using sulfuric acid as the catalyst. So you are going to review the lab manual for the mechanism that is presented in this experiment for the esterification. But overall, just want to make sure that you remember this reaction is an acid catalyzed reaction. Esterification also is known as condensation type reaction. Condensation is like a bigger umbrella. So you will learn about like Wittig reaction, preparation of alcohol using Grignard, or esterification when you have 2 organic molecules combined to give 1 organic or larger organic molecule, is also known as condensation reaction. But we're talking about esterification specifically. Esters are known to be, at this point, not harmful. They're used as additives, for like food additives to flavor food and drinks. And they have pleasant odor. And that pleasant odor kind of makes them to be used in the food industry, and is a big money-making machine, yes, for the food industry, because they don't have to pick cherries or strawberries to flavor Coke, Diet Coke, and sell it for that price. So for the first part of the experiment, I'm going to just go down to straight to the procedure. And for the first part of the experiment, I'm your lab partner. I'm going to perform the experiment. And since we don't have other groups, I'm going to make all 3 esters, A, B, and C. For ester A, we have methanol and salicylic acid. For the solid compound, based on the procedure, we are using 0.2 grams of the solid acid. And for the liquid acid, which is acetic acid, I would use like 10 drops. For the alcohol, I'm using all 3 of them are liquid, and I will use 20 drops of the alcohol. I use the test tube rack, and I label my test tubes A, B, and C. We are going to measure the solid compound and the liquid at the catalyst and bring back. Beside the catalyst, this reaction also requires heat. The heat around 80-degree temperature of the heat is good enough. So I'm going to start for me like preparing water bath, warm water bath to make sure that it reaches to 80 degrees. And while I'm measuring the mass and the volume of my reactants, I'm going to turn on the hot plate. So just basically set up the hot plate. I fill up a beaker, like a 250 ml beaker, halfway, leave it on the hot plate. I set up my thermometer using a thermometer clamp and a ring stand. Let this warm up while we are measuring the chemicals. Test tube A, where I have the salicylic acid. For salicylic acid, I need 0.2 grams. This point is a qualitative analysis, is not quantitative, but it's sufficient enough if we use 0.2 grams of this. We transfer to test tube A. And for our test tube B, I'm using benzoic acid, 0.2 grams of the benzoic acid for test tube B, 0.2 grams. So we can transfer that. Usually I fold this weighing paper for easier transfer. So I make a paper funnel and easily transfer. And to test tube C, which I'm using acetic acid, I would add the 10 drops of the acetic acid, which I have in the fume hood. So please follow me to the fume hood and see the rest of the chemicals we are adding. So to test tube C, just add 10 drops. Just count 1, 2, 3, 4, 5. And 10 drops. Now we add the acid. We're adding methanol to the first one. For ester A, adding 20 drops of methanol. 20 drops is about 1 milliliter. 1 milliliter, like if I just take 1 full dropper, that kind of satisfies the 20 drops. But for the purpose of this experiment, I'm just going to count it. 1, 2, 3, 4, 5. And 20 drops. For B, which is benzoic acid plus 1 propanol. And for ester C, we are using isoamyl alcohol. That's the common name for this alcohol. IUPAC name for this compound is 3-methyl-1-butanol. So you see either name is the same alcohol. So isoamyl alcohol or isopentyl alcohol or 3-methyl-1-butanol. Okay, this reaction is an acid catalyzed reaction. So we are going to add 5 drops of the sulfuric acid to each test tube. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And same for this one. 1, 2, 3, 5. I have 5 drops of acid. And we are going to place in hot water bath for 20 minutes. For the test tubes that we have the liquid, just stirring or agitating is going to be sufficient, of course, to mix well. But for the test tube A and B, when we have a solid compound, we want to use the stirring rod to mix it well. And occasionally, we are going to continue stirring it like occasionally. So we make sure the reaction is going. We leave this for 20 minutes. We want to make sure the temperature stays around 80. And if it's less than 80, we can continue heating. When it's 80, we turn off. If it's over 80, we have to remove the test tube from the hot water, because we don't want the alcohol to evaporate. So if the boiling point of the alcohol and the acid is high enough, it's okay for this water to start boiling, or the water bath temperature can go higher. But especially with the test tube A, when we have methanol, if the temperature of the boiling water or the hot water, it goes too high, it can evaporate the methanol before the reaction takes place, and then you'll be wondering why you can't smell the ester. So keeping the temperature properly or at the suggested temperature has its own reasoning. So it's not just a random number. While this is being heated up for the 20 minutes, I'm going to stir like occasionally, as I said, and also I'm going to prepare 3 small beakers with cold water, because after the 20 minutes, we're going to pour it into the cold water in a beaker to test for the odor of the ester. So for this 20 minutes, we are going to pause the video and come back. Okay, it has been about 20 minutes and the temperature around 80 degrees. I have measured 2 milliliters of deionized water and placed in every beaker or corresponding beaker. Now it's time to take this out, the test tube out of the hot water bath, and pour the content into the labeled beaker for A, and going to do the same for B and C. This is the C. So for B. Now, you have to kind of trust me, because you're not here to smell or test for the odor, but the proper way of it, it would be just to kind of waft the vapor toward your nose. You don't want to go like very close to it. And why you want to be like careful, even though you know ester, but remember we add sulfuric acid for this to get the reaction going, and you don't want to get too close, and you don't want to get too much of the acid in your to inhale it can burn you. So definitely it smells like the wintergreen. So you can record your observation, and I'll be your lab partner, or as I am your lab partner, you can trust me and record this one for wintergreen. For B, the smell is like cherry, and I can smell the cherry because I used to like pick cherry from the trees, and I know how that smells. It might be kind of, not easy to see like smell of the cherry, because you can taste cherry very well, but smell of the cherry, but definitely to me, it smells like cherry. So you can record your observation for B as a cherry, smell of cherry. And for C, definitely, banana is very strong smell of the banana. So we can identify these. You will see the note to take a screenshot of different steps of the video, or different timing of the video, different screens. Take a screenshot and include that in the lab manual. So just make sure to do that part. So we are done with part 1 of the experiment. Going to prepare and do the part B of the experiment, which is identifying unknown acid based on the order of the ester.